So that's my angle. That's what theta is literally defined as. Okay? So if I consider any point, it's just simply the angle which I've moved through anti-clockwise from the positive x-axis. Right? Okay, let me just make a quick sketch of that triangle over here. So I've got this kind of thing going on. Okay? I know that distance across there is x. I know that distance up there is y. That's my right angle, and that's my theta, and that's just worth 1. Okay? Now, what I want to do is instead of saying x and y, I want to make use of the trigonometric ratios that I know about. Okay? So let's think. Let's just remind ourselves of them. Okay? If I wanted to rewrite x, okay, if I wanted to rewrite x, would you be happy because I know the length of that side? It's just 1 by definition. Just 1 by definition. Okay? If I want to find x, so I'm comparing this side and this side, okay? What trigonometric ratio would I be using? So remember, this is my angle. This side would be my adjacent. This side would be my hypotenuse. And this side would be my opposite. Okay? So if I wanted to compare x, okay, I know that side there, it's worth 1. So if I want to compare the adjacent and the hypotenuse in relation to theta, which ratio would I be using? Adjacent and hypotenuse. Adjacent and hypotenuse. Cosine. Yeah? So I could say, okay, the cosine of my angle, in this case theta, would be the adjacent compared to the hypotenuse. In other words, x over 1. Yeah? Or, you're happy x over 1 is just x. So in other words, I could rewrite x simply as cosine of theta. Okay, because you're going to see x is just simply equal to the cosine of whatever my angle is. So x is equal to the cosine of whatever my angle is. Which means that when I come up here, okay, I don't have to write x anymore. Okay, I don't have to write x as my coordinate. I can say that x is just the cosine of whatever angle I've moved through. X is just the cosine of whatever angle I've moved through. Make sense? Yeah? Okay. What if I wanted to make a comparison between the opposite and the hypotenuse? Which ratio would I be using? Sine. Good. So I could say that sine of theta would be equal to opposite over hypotenuse. So in other words, y is just simply the sine of theta. Okay, y is just simply the sine of theta. In other words, y is just simply the sine of whatever angle I've moved through. Now you're kind of thinking, well, yeah, so what? Who cares, right? Well, what I've done here is by thinking about the unit circle, if I know the angle which I've moved through to get to that point from anti-clockwise from the positive x-axis, whatever my x-axis, whatever my x-coordinate is, that's the cosine of that angle. And then whatever my y-coordinate is, that's the sine of that angle. Does that make sense? Does that make sense? Okay. So here is what I'm going to do. Here's what I'm going to do, right? I'm going to create a graph. And I'm first of all just going to look at sine. Okay, I'm first of all going to look at sine. So here we go. Let's see if I can squeeze this in. Okay. Let's put it down here. This is 0, okay? So I'm just going to do a full turn. Okay, I'm just going to walk through a full turn. So I'm going to do 0 degrees all the way through to 360 degrees. And just because I don't want to sort of spend lots of time doing this, I'm just going to pick the points where it intersects through the axis, because they're really easy to work out what those angles are. Okay, really easy to work those angles are. So let's have a think. Let's first of all consider this point down here. Now, first of all, tell me what my angle is. Now, remember, angle is the angle which I've moved through anti-clockwise from the positive x-axis. So if I'm sitting there, what angle have I moved through anti-clockwise from the positive x-axis? 0 degrees. You happy? I'm just literally sitting there. I haven't gone through any angle yet. So in other words, when I'm sitting here, my angle is 0 degrees. Does that make sense? Okay. Now remember, I want to draw the sine graph first. Okay. So this is my angle. Okay, and this will be the sine of that angle on this side. Right. So at 0 degrees, what is sine of 0?
0.
It's 0 because it's just simply the y-coordinate. Yeah? So in other words, that y-coordinate just simply becomes the sine of whatever angle I've moved through, in this case 0 degrees. Does that make sense? Yeah? So I know that the sine of 0 degrees is just simply 0 there. That make sense? Good. Okay. Let's move up here then. Let's move up here. So what angle have I moved through when I'm sitting up there? So remember, I've started here. I've moved anti-clockwise from the positive x-axis. What angle have I moved through? 90 degrees, okay? So in that case, my angle is 90 degrees when I'm sitting there, okay? So if I want 90 degrees, let's do 90 degrees next. So there's 90, okay? What is the value of the sine of 90 degrees? Would you be happy it's just simply the y-coordinate? Okay, so I know that at that point there, my coordinates are 0, 1. So if I want the sine of 90 degrees, I just need to look at my y-coordinate. So the sine of 90 degrees should just be 1. Okay, sine of 90 degrees should just be 1. Okay, if that's 1 here. Right, okay, let's think about this point over here. So what angle have I moved through anti-clockwise from the positive x-axis? 180 degrees, good. So when I'm sitting there, my angle is 180 degrees, which means that if I want the sine of 180 degrees, what is that value?
0.
Good, because it's just simply the y-coordinate. So the sine of 180 degrees is just simply the y-coordinate, so it should be 0. Make sense? Yeah? Let's keep going. What angle have I moved through anti-clockwise from the positive x-axis if I'm sitting down here at this point here? Good. 270 degrees. So theta equals 270 degrees, which means that if I wanted the sine of 270 degrees, what would that be equal to? Good, it's just simply the y-coordinate. So the sine of 270 degrees is just simply -1. Oops. So the sine of 270 degrees is -1. Let's see if I can just fit it in. Good, it's down here. Right, and then finally, because I want us to do a full turn, if I did 360 degrees, would you be happy that I've gone all the way around the circle? Yeah. Okay, so I'm back here again. So I could say theta equals 0 degrees, or I could say this point here corresponds to theta equals 360 degrees. 360 degrees, okay? In which case, if I wanted the sine of 360 degrees, that would also be, what? 0. Good. So 360 degrees. We're back here at 0, okay? So have a look. All I've done is I've moved through 360 degrees and considered the intersection points at every 90 degrees. So this point, this point, this point, and this point, and then this point, and I've just considered what the intersection point is, and then that gives me the sine of that angle, okay? So can you see now that I have values of sine which are 0 degrees, which are 90 degrees, which before I couldn't get with my triangles, but also bigger than 90 degrees as well. Yeah? Make sense? Right, my question is, I've got 1, 2, 3, 4, 5 points. How am I going to connect them together? Straight line or curved line? Good. Why is it going to be a curved line? So why is it going to be that curved line? Let's have a think. Think about where it comes from. Okay, think about where it comes from. When I'm moving through my angle, okay, because it comes from a circle, are you happy a circle is a curved line? Yeah? So in other words, the rate of change of the circle is not constant. It's not constant. Think about it. Over here, I'm changing quite quickly. But when I get here, I'm changing much, much slower. And then I start changing quickly again. Does that make sense? Remember my tangent line, my pen, it's my tangent line. There I'm changing really quickly. Over here, I'm changing much, much slower. Then when I get back here again, I'm changing much quicker. Okay? So in other words, the rate of change is not constant, therefore I can't draw them together with a straight line, right? So I've got to draw them together with a curved line. So let's try this. There you go. There you go. Okay? So this graph here would be the graph of sine between 0 and 360 degrees. Okay? Couple of things to notice from this graph. What is the range? What is the maximum values and the minimum value of sine?
1.
Yeah, so that's the maximum and that's the minimum. Why? Why is the maximum 1 and why is the minimum -1? Why can't it be 2? Why can't it be 1,000? Why is it got to be bounded between 1 and -1?
Because it's a unit circle.
It's the unit circle, absolutely, right? So over here, the maximum value, which, well, the minimum value, sorry, over here, the maximum value which sine can be, the height of the circle, is going to be 1. And the minimum value is going to occur over here, which is going to be -1, right? So I've just chosen to use the unit circle, right? Now my next question is, could we have angles which are bigger than 360 degrees?
Yes.
what would that correspond to? So what, for example, would sine of 450 degrees mean in relation to the unit circle?
0? I don't know.
Have a think. So what I'm doing, if I'm doing 450 degrees, I've gone a full turn all the way round, right back to here, and then I've gone another 90 degrees further on. Yeah? And if I keep going for like the next one, it'll be over here, next one will be over here. So are you happy that actually this graph will just repeat again? Because it just corresponds to going round the circle again. Then if I wanted to go around the circle again, I get the same graph, okay? And I keep on going like that. So actually this graph carries on going forever and ever and ever and ever and ever and ever, right? Okay. Would negative angles make sense as well? Yeah? Because if you think about it, a negative angle is just going in the opposite direction, okay? So if I go backwards again, then I just get this thing going on over and over and over again. That make sense? Right? So actually, sine graph continues forever. It's indefinite, okay? And do you notice that it's periodic, okay? In other words, everything from here to here, okay, corresponds to one turn, one full turn of the circle. Then you just get the same thing again and again and again and again, okay? It's periodic, right? One final thing which I just want to talk through, we call this sinusoidal. This type of graph here, we call it sinusoidal. Literally because it follows the definition of sine, okay? So if you see this graph sort of in nature, for example, waves tend to follow this graph, yeah? Electricity, if you ever get the scope out and look at electricity, it follows this graph, okay? It's called a sinusoidal graph because it follows the idea of where sine comes from, okay?